A snake long enough to fill a school bus once slid through the swamps of South America, and it was strong enough to crush a crocodile between its coils. 60 million years ago, this was not a myth. It was the largest snake the world has ever known. Heavier than a car, wider than a truck tire. Its name is Titanoboa, and this is its story. Titanoboa was a snake, but calling it that barely covers what it was. It belonged to the same family as modern boas and anacondas, snakes that kill not with venom, but by wrapping around prey and squeezing until the heart can no longer beat. Titanoboa did the same thing on a scale nothing alive today comes close to. Adults are estimated to have reached over 40 feet long, some estimates stretch past 45, and weighed something in the neighborhood of 2,500 pounds, or about 1,100 kilograms. That is heavier than a small car. Picture a snake as long as a school bus and as thick around as a large tire, and you are picturing an animal that could rest its head on your shoulder while 40 feet of its body was still coiled somewhere behind you, somewhere between a hug and a hostage situation. This animal lived around 60 to 58 million years ago in the Paleocene epoch in what is now La Guajira in northern Colombia. Its home was a hot, swampy rainforest, the earliest tropical rainforest scientists have direct fossil evidence of, threaded with rivers and choked with heat. The fossils themselves came out of the Cerrejon coal mine, one of the largest open-pit mines on Earth, where machines cut away rock in search of coal and occasionally turned up something far older and stranger. One of the first vertebrae pulled from that mine was sent to the Smithsonian Institution, labeled as a crocodile bone. It sat that way for a while until a snake specialist unwrapping the fossil realized the shape was wrong for any crocodile. It was a snake vertebra, and it was enormous. Excavating anything from an active mine that size takes coordination with mining engineers as much as digging tools, since paleontologists have to work around active blasting and equipment on a tight schedule. In 2009, a research team led by paleontologist Jason Head announced what they had found and gave it a name that undersold nothing. Titanoboa cerrejonensis, the Titanic boa of Cerrejon. What made the discovery even stranger was the timing. Titanoboa was not swimming alongside the dinosaurs. It showed up only a few million years after an asteroid wiped nearly all of them out in a world still resetting itself. Something about that recovering world let a cold-blooded animal grow to a size no snake has matched since, and the reason why turns out to be written directly into its bones, a clue this story will come back to before the end. Before Titanoboa, most scientists assumed the recovery from that extinction took much longer to produce animals of exceptional size, and a snake this large, this early, forced a rethink of how quickly life rebounded once the dust settled. No one has ever found a complete Titanoboa skeleton, and that is normal for fossils this old. What paleontologists actually have are more than 100 vertebrae, pulled from at least 28 different individuals, and eventually, in a separate find years after the first bones surfaced, pieces of a skull. From those pieces, scientists reconstruct the whole animal the same way you could guess a person's height from a single vertebra, using the mathematical relationship between backbone size and body size in living snakes. Every boa and every anaconda alive today gave them a formula to work from. That is also why the size estimates come as a range rather than one fixed number. Some studies land closer to 42 feet, others push past 45. There is no argument that the animal existed or that it was immense, only debate over exactly how immense, and even the lower end of that range beats every snake alive today by a wide margin. Even the vertebrae themselves are informative on their own, since their exact shape lets researchers tell a Titanoboa bone apart from a similarly sized crocodile vertebra at a glance. Picture the body itself. At its thickest point, Titanoboa's midsection is estimated to have measured about 3 feet across. Roughly the width of a car tire stood on its end. A grown adult could not have wrapped both arms fully around it. The whole animal, stretched out, would have reached from one end of a school bus to well past the other with room left over. Its skin was almost certainly patterned rather than plain, Since every large constrictor alive today, from the green anaconda to the boa constrictor, wears camouflage suited to hiding motionless in water or undergrowth, and there is no reason to think Titanoboa broke that pattern. Unlike a python or a rattlesnake, it had no fangs built for injecting venom. Its head carried the blunt, backward curving teeth typical of a constrictor, teeth built for gripping and holding a struggling animal in place, not for delivering poison. The kill, when it came, was always going to be about muscle, not chemistry. Like every modern snake, its lower jaw was not fused at the chin, letting the two sides spread independently to work prey down its throat in stages rather than in one single bite. The skull, when researchers finally recovered pieces of one, told them something else entirely: what Titanoboa was eating. Fish remains preserved near skull material, pointed toward a diet built substantially around large fish alongside the turtles and crocodile relatives that shared its swamp, a mixed menu unlike most living anacondas, which lean heavily toward mammals and birds. That diet lines up with how Titanoboa most likely moved. Its enormous bulk would have been a burden on land, where every pound had to be dragged by muscle alone, but in water, buoyancy did that work for free. Most reconstructions place Titanoboa spending much of its life submerged or half-submerged, gliding through slow rivers and swamp channels with only its eyes and nostrils breaking the surface, the same ambush posture a modern crocodile uses. On land it could still move, snakes always can, but water was almost certainly where this animal was most dangerous and most at home. A 1,000-pound predator turned nearly weightless the moment it slid beneath the surface. A single lung, elongated to match its body shape, is standard in snakes this size and would have let it stay submerged for extended stretches while lying in ambush. Titanoboa did not live alone in that swamp, and it did not need to look far for something to eat. The Cerrejon rainforest was thick with other outsized animals riding the same wave of post-extinction recovery. Turtles the size of truck tires, some with shells over 5 feet across, paddled through the same channels. Long-snouted crocodile relatives called dirosaurids patrolled the water alongside them, animals that elsewhere in the world hunted fish and small prey of their own. Overhead, palm trees and early flowering plants formed a canopy thick enough to keep the swamp floor shaded and steaming. Everything about the place ran hot, wet, and enormous, an entire ecosystem stuck at maximum size in the millions of years right after the dinosaurs disappeared. Before mammals had grown large enough to take over the roles reptiles were still filling. Insects the size of dinner plates and early relatives of catfish rounded out a food web running almost entirely on heat and abundance. For an animal this size, hunting did not mean chasing. Titanoboa almost certainly ambushed, lying motionless in the water with only its eyes above the surface, waiting for something to swim within reach. Once prey was close enough, a strike and a coil finished the job in seconds, muscle contracting hard enough to stop a heart rather than break bones. Fish made up a real part of that diet, more than scientists expected from an animal this size. But Titanoboa was not limited to fish. Something close to its own weight, a young dinosaur or a smaller turtle pulled from its shell, was well within reach for a predator that could apply that much force. There is no evidence Titanoboa hunted in groups or showed any social behavior at all. Every fossil found points to a solitary animal, which tracks with how nearly every large constrictor alive today behaves. Digesting a meal that size was slow work too, and a well-fed Titanoboa likely went weeks without needing to hunt again, conserving energy by staying still for long stretches between kills. At the top of that food chain, an adult Titanoboa had essentially nothing to fear. No predator in that swamp came close to matching its size, which meant the only real limits on this animal were not teeth or claws, but temperature and food supply. That mattered more than it might sound. A cold-blooded body that size needed the world around it to stay hot consistently for years on end, just to keep functioning at all. Titanoboa's very existence depended on a Paleocene climate running unusually warm, and that dependence would eventually matter far more than any rival predator ever could. Even a young Titanoboa, still small enough to be vulnerable, would have grown out of danger within its first few years, since almost nothing in that ecosystem could threaten an animal on this trajectory for long. Titanoboa is only known from a narrow slice of time, roughly 60 to 58 million years ago, and then it is gone from the fossil record entirely. No later Titanoboa bones have ever turned up, not in Colombia, not anywhere else, despite decades of paleontologists searching Paleocene and early Eocene rock layers across South America. Whatever happened to this lineage, it happened relatively fast in geological terms, well within a few million years of the last confirmed fossil. No snake since, in 60 million years of trying, has grown anywhere close to the same size again. That absence has been checked against rock layers spanning millions of years past the last known specimen, and the silence is consistent, not a gap explained by simply failing to look in the right place. Researchers point to several overlapping causes rather than one single culprit. The leading explanation ties directly back to temperature. As the Paleocene gave way to a cooling world, even a modest drop in average heat would have made an animal this size, this cold-blooded, impossible to sustain, since a body that large needs a hotter environment than a smaller snake just to keep its metabolism running at all. A changing rainforest may have played a role too, as the plant life cerrejonensis ecosystem depended on shifted over time, potentially thinning out the dense, humid cover this kind of ambush hunting needed. Rising competition is another candidate, as early mammals slowly grew larger and began filling predator roles that reptiles like Titanoboa had held almost by default in the empty years right after the dinosaurs vanished. None of these explanations cancels out the others, and most researchers now treat the ending as several pressures closing in on this animal at once rather than any single dramatic event. A more mundane possibility sits alongside the others too. The fossil record itself is incomplete everywhere, and it is possible smaller pockets of a shrinking Titanoboa population survived somewhat longer in warmer refuges that simply have not been excavated yet, leaving the true end of the lineage still slightly open. The species didn't vanish all at once, it just got quieter and quieter across the generations until quiet became permanent, the way most endings actually happen, unlike the movies. What was left afterward were only bones, buried in coal for 60 million years, waiting for a mining shovel to finally drag them back into the light. Now for my favorite part, a few fun facts your friends probably don't know. Titanoboa's name is not subtle. It combines Titan, from Greek mythology's giant gods, with Boa, and its full name honors the coal mine where it was found. A juvenile Titanoboa, fresh out of the egg, would still have been longer than an adult reticulated python, one of the largest snakes alive today, and in 2024, scientists in India described Vasuki indicus, a snake possibly rivaling Titanoboa in length, though nothing found so far beats Titanoboa's sheer bulk and weight. A Titanoboa shedding its skin in one piece would have produced a strip of skin longer than most swimming pools. Cerrejon, the mine that produced Titanoboa, is still an active coal operation today, one of the largest open-pit mines on the planet, meaning fresh fossils could still be sitting in rock that has not been cut away yet. Modern green anacondas, the heaviest snakes alive now, would need to roughly triple their weight just to match Titanoboa's average bulk. Despite its size, Titanoboa's brain and eyes were proportionally tiny compared to its body, similar to every snake alive today, since a constrictor this successful never needed sharp eyesight to hunt. I hope that gave you a real sense of just how big this thing actually was. Let me know in the comments which extinct animal you want to see here next, and if you enjoyed this one, a like and a subscribe genuinely helps this channel grow. And until then, stay curious. Thanks for watching. Watch this video next and subscribe for more.